Student, I am going to discuss the question number 16 of paper number 2 of JEE Advanced 2015. Just we go for the question. In a given question, a spherical body of radius r consists of a liquid of constant density in equilibrium under its own pressure of gravity. Then we have to calculate the pressure at different point. To calculate the pressure expression at different point, just we assume the solid spherical drop of radius r. We assume an element at a distance r of thickness dr, the mass of this is dm and density is rho. The pressure just inside this spherical shell is P and outside this is P plus dP. Okay. If you multiply by small area, then it becomes force, and this is also become force. Okay. This is the diagram. Now, as we know that the gravitational field intensity at a distance r is given by 4 by 3 pi rho g multiplied by small r. This is the standard value of E as a function of a small r. This is constant, this is constant, constant, constant. So that to simplify the calculation, just we can write E-jee is equal to say new constant C dash r. Okay, this is the equation number 1. Now we calculate the expression of force F. The force F on a elementary part is given by dP, small pressure multiplied by small area, dP into ds. Because as for from the equation number 1 we can write minus, because pressure is decreasing with respect to distance, dm into Eg. Now we can write dm is equal to volume into density. First we write down the density, volume of a small element, ds into dr into Eg. Okay, this is dp and this is ds. ds and ds cancelled. Now expression of pressure is given by dp is equal to minus rho, Eg is equal to C dash r multiplied by dr. Now with a proper integration, at the surface we are assuming the potential pressure 0. At the surface small r will be equal to capital R, so pressure is 0. Very important. And at a certain distance r, the pressure is say P. Now by integrate this and put the limit, this is lower limit, upper limit, minus rho C dash by 2 from r to small. Okay. By adjusting the negative sign, we can change the limit, so that final expression of pressure is given by P is equal to rho C dash capital R square minus R square by 2. So the equation number 2. Now we move on the question. In a option number B, we have to calculate the pressure ratio of pressure at a 2 different points. From B option, small r is equal to 3r by 4. And in second case, small r is equal to 2r by 3. And we have to calculate the ratio of pressure at a 2 different points. These 2 different points. So we can say R1 and R2. This is the constant part, so that P1 by P2 is equal to R square minus 3R by 4 whole square upon r square minus 2r by 3 whole square. Now we will solve this equation, then we will get 63 upon 80. So that this is the option number B. Now again we select the option number C for a 2 points R1 is equal to 3r by 5 and R2 is equal to 2r by 5. Now pressure P1 upon P2 is equal to R square minus 3r by 5 whole square upon R square minus 2r by 5 whole square. When we will solve this expression, we will get 16 upon 21. So it means option number C is also correct. Option number C is also correct. So that final answer of this question will be B, C. Thank you.
I am going to discuss JEE Advanced 2015 paper 2 code 5 paragraph 1. This paragraph consists of 2 questions, and this basically is question of Hall effect. Hall effect is a very popular effect which is discovered by Mr. Hall, great scientist. What the Hall effect say? In this question, examiner is saying we have 2 different metallic strip. I'm showing you the figure of one such strip. For 2 different strip, length is same, but the thickness and the width is different. Both have same amount of current, and in the both strip we have applied some external magnetic field in upward direction. What will happen because of this magnetic field? Let's discuss about this. As current is flowing in this direction, so electron actually is moving in this direction. This is the electron velocity Vd. We can also calculate what is the velocity of electron by this formula I is equals to NEA Vd. I is already given, and E area is the cross-section area through which this current is flowing. If you see the direction of current, you can say cross-section area is this area, and this area will be D into W. So it is D, it is W, it is Vd. From here, somebody can calculate Vd, like we will calculate Vd. Now what is the need of Vd? We will understand this later on. Ne, D, W. That we have calculated Vd. Because this electron is moving, any charged particle when moving the magnetic field experience magnetic force. Same happened with electron. Electron is moving in this direction, magnetic field is in upward direction. So electron will, you can determine the force on the electron. This is the magnetic field, electron is moving in this direction. So the magnetic force will act on the direction just in this direction. So magnetic force will act this way. And therefore, these electrons start drifting toward this side, this face. His name is given by the examiner point M. This is face M. In the same face, in the back side of this, you can say another face is there, which is N. So electrons start drifting towards the M because of magnetic force. And as soon as electron will come, there will be minus charge will accumulate because of electrons, which will come and sit here. And because of electron drifting toward this side, positive charge will come on the face N. And because of this positive and negative charge on these 2 opposite faces, an electric field gets developed in this direction from positive to negative. Now what does electric field do? This electric field exerts another force on electron. Now electron is experiencing 2 forces together. One is magnetic force, another is electric force. And you see the direction of both forces. Magnetic force is acting in this direction, but electric field is in this direction towards you. So electron will experience electric force in the backward direction. Now these 2 forces are in opposite direction. When these 2 forces are in opposite direction, what will happen? One day will come, and that one day will come very soon, when these 2 forces will become together, cancel each other, and then the net force on the electron will be 0. In that scene, in that case, electrons stop drifting toward it, but till that time, lots of electron has already come, so minus plus charge has already developed, and because of that, a potential difference will create between phase M and phase N. F magnetic become equals to F electric. We can calculate by this the electric field which develop across the phase M and phase N. Magnetic force is E Vd B and electric force is E into E. From here we can calculate E is equals to Vd into B. This is the electric field. Now if we know the electric field, we can calculate potential difference. So potential difference between phase M and N is equals to V and it is equals to C. If this is the electric field and somebody asks you potential difference between 2 points, this electric field is uniform because it depends on Vd and B and Vd both are uniform throughout the section. So electric field is uniform, and in uniform electric field potential difference is given by E into separation between these two phases. So it will be E into W. When you will calculate this potential difference, put the value of E and W. So E is equals to what? E is Vd B W. I told you we need Vd. This time we need Vd and we have already calculated Vd from this equation. So from equation 1 you will put Vd here. When you will put Vd here, you will get V is equals to I N E D W. Here on the upper side we will put B and W. You can see W get cancelled out and V will be I B upon N E D. So now we have the expression for potential difference between phase M and phase N, and actually examiner is asking only this one, what is the potential difference? If you see the question number first of paragraph 1, question number 17, what he is saying, 2 strips we have of same material. Same material mean we have same value of N. So N is constant in question number 17 of this paragraph. Examiner is saying the length are same. So length are not coming in the picture. So we will not worry about length. We will worry about their thickness. Thickness are different. D1 and D2 are 2 thickness in question number 17. And the magnetic field are also same. Now what examiner is saying, magnetic field is same, so B is also constant. So we depend on what? I is same, B is same, N is same, we depend on D. So we can say V is inversely proportional to D for question number 17. Now first option say width are same, no need to see width because V is not depending on the width. But D1 is equals to twice of D2. It's clearly show that potential difference across the strip 1, V1 is equals to V2 by 2. So from here you can say V2 is equals to twice of V1. It's mean option 1 is your answer. So one answer is A. But then you have to check another answer. If you see the B option, that will not be the answer because that say W1 is equals to W2, D1 is equals to 2D2, and D1 is equals to 2D2 and V2 is equals to E1, but we have already proved that V2 is not equals to E1, V2 is equals to 2E1. Similarly, if you see the C option, that will also be wrong. If you see the D option, in D option, D1 is equals to D2. Therefore, V1 is equals to V2. So this will be the answer. So answer will be A and D. This is the question number 17. This paragraph also have one more question, that is question number 18. So let's talk about question number 18. In question number 18, these 2 different strips have same length, have same width, have same thickness, but the material are different. So this time D is constant. D is not variable. This time width is constant, width is not variable, but N is not constant. This time N1 and N2 are 2 different values. Now what examiner is saying? He is asking in option 1 when B1 is equals to B2 and N1 is equals to twice of N2. From the formula you can say V is actually proportional to B upon N. If B is same, then V is inversely proportional to N. And if V is inversely proportional to N, so if N1 is equals to twice of N2, therefore we can say V1 is equals to V2 by 2. That is V2 is equals to twice of V1. So option A is the right answer. Similarly, if you check the option B, it will automatically wrong because option B is talking about same condition, but he is saying V2 is equals to V1, so it cannot be answer. If you see option C, it is saying V1 is equals to 2V2 and N1 is equals to N2. So when N1 is equals to N2 and V1 is equals to V2, V is proportional to B. So V1 is equals to twice of V2. So V2 is equals to 0.5 V1. So this can be the answer. This should be the answer. So answer will be C also. So final answer we can say of question number 18 is A and C. Thank you.
We will discuss question number 19, paper 2, code 5. This is related to paragraph, and this paragraph consists of two questions, question number 19 and question number 20. So first of all, we will read the paragraph along with the question number 19. Okay, paragraph 2. Light guidance in an optical fiber can be understood by considering structure comprising of thin solid glass cylinder of refractive index N1 surrounded by a medium of lower refractive index N2. The light guidance in the structure takes place due to successive total internal reflection at the interface of the medium N1 and N2 as shown in the figure. All rays with the angle of incidence I less than a particular value Im are confined to the medium of refractive index N2. The numerical aperture of the structure is defined as sin Im. Okay, this is our paragraph. Now question number 19. For two structures, namely S1 with N1 equals to root of 45 by 4 and N2 equals to 3 by 2 and S2 with N1 equals to 8 by 5 and N2 equals to 7 by 5, and taking the refractive index of water to be 4 by 3 and that of air to be 1, the correct options are. We have been given 4 options and we have to check which are correct among all 4 options. Okay, so let us first of all let us understand what is the meaning of paragraph. It has been given the mechanism of optical fiber in this paragraph. Here there is a core and it is a cladding. This is inner material, that is called core, and the surrounded material is called cladding, that is called N2. Here the refractive index N1 is greater than N2. The refractive index of core is greater than cladding, and in the optical fiber the light ray are getting totally internally reflected at the interface of core and cladding as shown in the diagram, and we have been defined a term that is called numerical aperture, that is called sin Im. Here this Im has been defined as all rays with the angle of incidence less than a particular value. Okay, so this is the Im is the maximum value for which these light rays are getting total internal reflection at the interface of core and cladding. Okay, and now we have to calculate, we have to check all 4 options in this case. So first of all, we have to calculate what is the value of sin Im, that is numerical aperture in this case. As we know, in this case that at point B we are having an incidence of total internal reflection here. So what is the case of total internal reflection? If you will see here, for the total internal reflection, let us say the C is the critical angle. All we know the meaning of critical angle. So for the critical angle, we can say that sin C is equal to N2 by N1, and we can write the value of cos C in the terms of N2 and N1, and that will be equals to root of N1 square minus N2 square divided by N1. So this is my value of sin C and this is the value of cos C. As we know, the critical angle is the angle at which a light ray, when coming from the denser medium at the interface of rarer medium, gets totally internally reflected. That is the critical angle. Okay, so the value of sin c is equal to n2 upon n1, and with the help of sin c we can get the value of cos c. Okay, here for the cos c, this is the critical angle. Of course, this r dash has to be greater than critical angle, then only the total internal reflection can take place. So if r dash is greater than c, then cos r dash has to be less than cos of c. If the angle will be greater, the value of cosine will be lesser. So r dash is greater or equal to c, that is the condition of TIR, that is dash is less than or equal to cos of c. If we will see here, let us say we will take the triangle ABO. So here I can say that r plus r dash is equal to 90 degree. So I can write r equals to 90 degree minus r dash, and if I want to write the value of sin r, it will be equals to sin 90 degree minus r dash, and that can be written as cos r dash. So sin r is equal to cos r dash. So cos r dash, I replace it by the sin r. So sin r is less than cos c. Okay, so this is sin r, and sin r, if I will put here at point A, if I will apply the Snell's rule, I can write here, see here, mu sin I, applying the Snell's law, according to the Snell's law, mu sin I can be written as, here the refractive index is n1, so I can write here n1 sin r, and sin I is equal to n1 sin r divided by mu. So this is value of sin I. Okay, so if I will calculate the value of sin I by putting the value of sin r from this value, so sin I will be equals to n1 divided by mu, and this sin r is always less than or equal to cos c. Okay, so n1 sin r, and n1 sin r is always less than or equal to cos c. So can I write here in this way, n1 upon mu cos of c, and I already calculate the value of cos c as root of n1 square minus n2 square upon n1. So I will write here the value of cos c, n1 square minus n2 square upon n1. So this is my value of sin I. Okay, so I will omit here, and the value of sin I is root of n1 square minus n2 square divided by mu. But I have to calculate the value of numerical aperture, and that is equals to numerical aperture is defined in the question, that is equal to sin Im. But I know that the value of I, the angle of incidence, for the incidence to happen should always be less than or equal to Im, as given in the question. So sin I is always less than or equal to this value. So can I write here sin I is always less than or equal to sin Im. Therefore, from equation, let us say this is my equation 1, this is my equation 2, I can write the numerical aperture, that is equal to sin Im is equal to root of n1 square minus n2 square upon mu. So this is my numerical aperture value. Now I have to check the options A, B, C and D has been given in the question. For my simplicity, what I will do first, I will calculate the value of root of n1 square minus n2 square, because if I will read the options, the value of n1 and n2 is not changing at all. Only the value which is changing in the options is mu. So first of all, I will calculate for the structure S1. For structure S1, N1 for a structure N1 for a structure S1, root of N1 square minus N2 square is equal to, I am just putting the values as given in the question, root of N1 square. So N1 is given as root of 45 by 4 whole square, and N2 has been given as 3 by 2, so it can be written as 3 by 2 whole square. So if I will calculate it, it will be equals to root of 45 by 16 minus 9 by 4, and this can be written as root of n1 square minus n2 square can be written as 16, and this will be equals to 45 minus 36 upon 16, and that will be equals to 3 by 4. So this is the value for structure S1. Similarly, I will calculate for structure S2 also the value of root of n1 square minus n2 square. For the value of n1 for structure S2 is given as 8 by 5 whole square minus 7 by 5 whole square. So this will be equals to 64 minus 49 upon 25. I can see the value as 15 upon 25, and that will be equals to root of 3 by 5. Now the calculations becomes a little bit easier for me, as I have already calculated the value of a numerical aperture. I will just write it here. The value of numerical aperture, as I have calculated, as root of n1 square minus n2 square divided by mu. Okay, so we have already the value of numerator for a structure S1 and for a structure S2 also. So the option A, numerical aperture of S1 immersed in water is the same as that of S2 immersed in a liquid of refractive index 16 by 3 root of 15. So in the case A, for structure S1, the refractive index has to be taken for water, and that has been given in the question as 4 by 3. So let me check the numerical aperture. So for the structure S1, the numerical aperture, I will just put the values. Root of n1 square minus n2 square is 3 by 4 upon mu1, that is 4 by 3. If I will calculate it as, it will be the 9 by 16. For a structure S2, the refractive index is given in the question as 16 by 3 root of 15. So for the numerical aperture for S2 will be equals to, see here the value of root of n1 square minus n2 square is root of 3 by 5 divided by 16 by 3 root of 15, and this will be equals to 3 root of 3 multiplied by root of 15 divided by 16 root of 5. Okay, and here I can see here that this will be 3 into 5, so 5 will be cancelled by this one. Here I will see 3 into 3, 9 by 16. So option A is correct, because the numerical aperture for structure S1 and for S2 are same, that is 9 by 16. So option A is correct. Now we will calculate the option B. Again we have to repeat the same process 4 times. For Option B, the refractive index mu1 has been given as 16 by root of 15. So the numerical aperture value will be equals to, I am just putting directly the values now, 3 by 4 divided by 16 by root of 15. It can be written as 3 root of 15 divided by 64. Okay, and for structure S2, the refractive index mu2 has been given as immersed in water, and for water the refractive index is 4 by 3. So I will check numerical aperture value of 2, that is root of 3 by 5 divided by mu2, that is 4 by 3. So that will be equals to 3 root of 3 divided by 4 root of 5. Now I have to see whether both are equal or not. Now I can see that this is not equal. Okay, so the option B is wrong. This is my option B. Option A is correct, option B is wrong. Okay, both are not equal. Now I have to check option C in the similar way also. For option C, for structure S1, the refractive index is for air, that is 1. So the numerical aperture value will be equals to 3 by 4 divided by 1. Okay, and for structure S2, the refractive index is given as 4 by root of 15. Okay, let us put the value, numerical aperture value 2, that is root of 3 by 5 divided by 4 root of 15. So that will be equals to root of 45 divided by 4 root of 5. I would see here that this will be equals to root of 9, that will be equals to 3 by 4. Yes, the option C is again correct. So option C is correct, and the final option D, again we have to repeat the same process. It is the calculative question. Numerical value for S1, here S1 is placed in air, so I can write it here 3 by 4 divided by 1, and for the structure 2, this is equal to root of 3 by 5, that is root of n1 square minus n2 square, and it is placed in water. So this is 4 by 3. The refractive index of water is 4 by 3. It is equals to 3 root 3 upon 4 root of 5. Both are not equal. So option D is wrong. So our answer is option A, and option C is the correct answer. Thank you. Good morning, students. Now we will discuss question number 20, paper 2, code 5. It is the successive question to question number 19 of the paragraph 2. Question number 20. First of all, I will read the question. If two structures of same cross-sectional area but different numerical aperture NA1 and NA2, given that NA1 is greater than NA2, are joined longitudinally, the numerical aperture of the combined structure is. This question is theoretical question. We will discuss here. We have already discussed in the paragraph that the angle of incidence should be less than the value of Im for the transmission that is confined to the refractive index N1 of the core. For the optical fiber phenomena, the total internal reflection that is taking place at the interface of core to the cladding, that is only possible when the value of angle of incidence should be less than or equal to Im, and the numerical aperture is defined as sin Im in the paragraph. Now the two different structures of different numerical aperture are joined longitudinally. So we have to see here that because numerical aperture 1 value is greater than numerical aperture 2, therefore sin Im2 is less than sin Im1. Okay, sin Im1. Therefore, Im2 is less than the value of Im1. But as we know that the value of I should always be less than or equal to Im. Therefore, for the angle of incidence for the transmission, the I should be less than or equal to Im. But here, if we will compare the Im1 and Im2, Im2 is having the least value, so the angle of incidence should be less than the lesser value among both. So I should be less than or equal to Im2. So the numerical aperture for the combined combination should be numerical aperture 2. Okay, because we are having Im value 2, that should be the maximum value that can be of angle of incidence. So our option will be D. So answer D is correct. Thank you.